9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
Nuclear weapons are scary, right? So, I want to talk about nuclear weapons and what they have to do with electricity. But to get there, first we've got to start with what we're seeing in these videos. So, let's go back a little bit and let's take a look at some of these scenes. Now, when the bomb goes off, there's a huge light, and that light burns everything it touches. Now, we know of another technology that does exactly the same thing, and that's laser light. Now, laser light is polarized, and that's important. But beyond the polarization, the light that goes off from the nuclear weapons is like laser light, except it goes out in every direction, and the intensity is just off the scales. So when you watch this video, you're going to see the light happens and everything burns. Okay, the same thing happens with a laser. If you shine the laser on something flammable, as soon as the light hits it, that thing starts to burn. Okay, so you're going to see the light, everything starts to burn, and then the shock wave catches up to the light because the light is way faster than the shock wave. So the light hits, burns instantly everything it's touching, and then the shock wave catches up and knocks it down. So let's take a look. Light goes off, everything is absolutely burning. Anything that light can burn is burning in this picture, instantly on fire. It burns for a second, and then the shockwave catches up. Bang. Okay, so then there's two pieces to this explosion. There's the piece that makes the light and the piece that makes the blast. Okay, so what would a nuclear blast without the blast be? Well, I submit to you it would be an arc flash, just an electrical arc flash. It's just made in a really funny way. Okay, so let me explain. Let me tell you a story real quick. I was on a job and I was welding, and I was very irresponsibly welding with a cut-off shirt on. I laid down 3 welds, and my arm all of a sudden was super itchy, and I was scratching it, and I was like, I looked down and I was like, oh man, all of my skin that was exposed right here is red. And actually, I did this to myself twice before I figured out what I had done was I had sunburned myself. And I realized this after I started to peel like a sunburn. Okay, now this is incredible because I laid down 3 welds that were maybe, let's say, maximum 3 seconds each. So under 10 seconds of exposure to this light. And of the light that came off of that weld, only a tiny sliver of it hit my arm right here. Now, that light, if you were to reflect it all down and send it out like a laser, would make an extraordinarily powerful laser. But if we change the materials that we're welding and we got the weld to happen on its own, well, then we can make a great big explosion, right? So what you do is you take some uranium and you polarize it. And when you polarize it, it becomes an electret, except this electret's made of a uranium. And uranium is super, super duper powerful. Well, by powerful, I mean it's going to make a really, really strong electric field around it, just like an electret, okay? And then all you have to do is slam them together. And when they slam together, what happens when you get two electrically charged bodies that bump into each other? Well, what happens when you touch your spark plug, your jumper cables together? You get a spark, right? Well, if you took two highly charged pieces of uranium and you smashed them together, what would happen is they would try to weld together. But since it's such high electricity, it won't weld. It's just going to make an arc flash. And this arc flash is going to be a little bit weird because since the material is an electret already, you don't need any input of power to make the weld sustain itself. So when the weld starts, it will feed off of the field produced by the material. And that energy will consume it. And as it gets consumed, you're basically welding two pieces of weird material together. And when this happens, you get not a weld that's nice and controlled, you get a humongous arc flash. Now, aneutronic nuclear weapons are all the rage, right? What would an aneutronic nuclear blast look like? Well, it would look a lot like this, except you wouldn't have the shock wave. Okay, well, what do we know of that doesn't make a shock wave, but also rips material to shreds and can destroy stuff? Arc flashes. Arc flashes do that. Arc flashes in really close vicinity cause this to happen. So, how then do we remove the shock wave from the nuclear explosion? You don't make any containment. You just make it pure arc flash. So when you do this, what would it look like? Well, I think we have an example of that. And we're not going to go too deep into this, okay? I just want to pull it up quick. What would it look like if we had a nuclear weapon that didn't make a shock wave? Well, if we wanted that thing, what we'd need to do is we'd need to have one or more. Technically, we need at least three because you need to make containment. 2 points only make a line. 3 points make containment. Means you can make a circle or triangle, whatever. And then what you want to do is you want to crank up the amount of electricity in this flash and shrink the amount of time that it happens. That way, this doesn't create a shock wave. It's just an electrical arc flash. And that would look like that. It would look like a blip of light. Before I end the video, I'm going to tell you one more story. Same job. I was working on a 440 volt wall. Okay, and we're not going to talk about what this was for or anything. I'm just going to tell you the story on what happened. Okay, so I'm working on a wall, and the wall has 440 power to it, and there's a bunch of circuit breakers on this wall. Okay, and the wall of circuit breakers is for if we need to do maintenance to some of the machinery. You come over here and you turn the power off at the breaker, and that kills all of everything that moves, so that we can go in behind and we can do maintenance on the machines. Well, the guy I'm working with was kind of trying to skirt corners, and so the wall is still on, and we had one of these breakers kind of out, and I have it in my hands this close to my face, and I'm supporting it, okay? And he moves a wire, and his head is over here, I'm right here, and a 440 flash goes off right between us. Okay, now we got super duper lucky because neither of us actually got hit, But this flash was really close to my face. And you know what was weird about it? I didn't feel any wind. No wind, no disturbance of the atmosphere around me, nothing blew away, nothing touched me, so I didn't get zapped either. So, an aneutronic nuclear weapon would look a lot like an arc flash. A very fast, very powerful arc flash. So if you like learning about hidden science, go ahead and smash that like button, hit subscribe, and be a free thinker.